this section, we are going to design hashmap. The big problem 706 is intended to design hashmap. Give you a brief background about hashmap. In Golang, a map is a powerful, versatile data structure. Golang map is a collection of pairs by key value. It's key value store basically. It's widely used because it provides fast lookup and be able to retrieve values, update, and also delete with O of one complexity. Read through the problem statement here. Design a hash map without using any built-in hash table libraries. So you're not supposed to use any hash table libraries. Implement my hash map class and then implement these hashes or features. So we have a constructor here, my hash map, that's going to initialize object of empty map. And then we have three functions. Put function, the get function, and the remove. Function takes two parameters, both of type integer value. Here, key is integer. Could be any other data type also in a general program, but here the expectation is integer key. The value is also. The function is to insert key value pair into the hash map. The key already exists in the map. Update the corresponding slot. And so key value pair will have a slot, as we have seen in the table during the overview session. That function takes input parameter key, which is of type. So here we have an int key and it needs to be int key here. The expectation is the return value for the specified key, that is map. Minus 1 if the map contains no mapping for the key. And then finally we have remove function. This basically performs deletion or removal. Removes the key and its corresponding value from the map if it is available in the map. That's it. Here is an example. Example 1 performs some operations. It initializes or instantiates the hash map object, performs some put operation followed by get operation, and then put and get juggled up together, also perform some remove function and so on. With this background and constraints, even here, we'll go ahead and implement it. We are going to take a visual walkthrough and discuss about the steps required to design a hash map. We are going to make use of slice to design hash map. So here is a structure, my hash map that is defined and that's going to contain the slice type. This is the slice declaration. We have not instantiated it. So we are going to instantiate the slice with 8 elements in struct because slice is a dynamic variable length view of an array. With this, we are going to have my hash map defined as a wrapper for the slice. Initially, we are going to have all of the elements in the slice initialized to -1. This helps us to map key values when entries are not made into slots. We'll now discuss the walkthrough with explanation. Here, we are going to instantiate the hash map. So when hash map is initialized or instantiated and later filled with -1, it is empty. We then start with put operation. We say value 1 at P1. So we are looking at this and going to replace 1 at 1. The map now holds valid entry 1 1. With the second operation, we have value 2 at index 2. So that goes like we have two valid entries in the map now, which is 1 1 and 2. With the third operation that performs get on 1, here it goes returning value 1. The map doesn't change. It still remains 1 1 and 2 2. When we perform get free, there is no value available at t free and therefore it returns minus 1. The map remains unchanged. Now with 2 1 at t slot 2, we already have a value here. However, as per the problem definition, it's expected to be replaced. So we're going to insert 1 here. The map now is 1 1 2 1. Further, when we do get 2, we get value 1, which is that slot. And next, when we attempt to perform remove 2, which is a third operation, we do not purge it, but just invalidate it by making it minus 1 at the value. Finally, when we do get 2, we have the minus 1 returned because there is no value available after the removal that we just previously. Current value of the map is just 1. And so goes with the explanation we will implement. Now we are going to build a design hash map without using any built-in function from here. We want to define hash map here. For the sake of building hash map from scratch, we are going to make use of slice. I'm going to say my map slice of type in. So I'm just declaring the slice type variable here, and that needs to be instantiated somewhere down the line. We will instantiate that in the constructor. So instantiate the object here, hash map object. The constructor expects instantiation and return of my hash map. So I will return my hash map here. And that initialize my map slice. Let me initialize that with my local map slice. And now here I need to define my local map slice. I'm going to create it with make. I'll keep size of 1024 by 1024. I need to keep it pretty big because of the constraints here. Constraint says that key and value ranges somewhere between 0 and 10 power 6. And the most 10 power 4 calls will be made to put get and remove function. So you can assume something between 10 power 4 and 10 power 6 number of slots to be expected in the hash map that we are going to build. So let's keep this up. And here, as you see, when the slot is not valid or if it does not have a valid value, it expects the value to be initialized with minus 1 here, mapped with minus 1. So we need to initialize the slice with minus 1. For that, I'm going to run over the slice and initialize it with minus 1 in range of my local map slice. My local map size of I is equal to minus 1. Basically, I'm going to initialize every slot in this slice with minus 1. That's it. So this is about initialization of the class. This is about creating the slice. And then we return it. That's it. Now we are left over with three primary functions, put, get, and remove function. We'll implement it one by one. Function performs insertion into the hash map key value pair. It takes two input parameters, key and value, both of type integer. So insert the key value pair into the hash map. This is the function of the call. So it's as simple as initializing the variable this dot my map slice at given slot key with value. That's it. It's as simple as that. Next, we have the get function that performs fetch operation of a value at the given key. So fetch the value at given key in the hash map. So this is as good as look function and it expects to return integer value. So we will return this dot my map slice of key. That's it. So we are going to get the value, retrieve the value from the slice at a given slot key and then return it. We are done. And the last function we need to implement is the remove operation. This basically purges the key value pair from the hashed map. So purge the key value pair from the hash map. Basically, we are not going to remove the key value pair from the hash map, but just reinitialize it with -1, the given key here. So this dot my map slice of key is going to be reset or reinitialized with -1. That's it. We are done with the implementation. Let us perform a quick sanity check. Looks okay. We'll take a look at the test case. There's just one test case here, which is corresponding to this example that we have already discussed both over the description section and during the visual walkthrough. So it's time to now run. Pretty good. It's accepted and maybe the initial test cases have run pretty well. We'll take a deeper dive by letting it pass through additional test cases that walk through these constraints by submitting. Perfect. The implementation is decent and we have been able to demonstrate and implement hash table from scratch without using any built-in function. That's it.